All right, 29 minutes, 40 seconds. We'll see how we do here. If you would have, I'll be really transparent here. If you would have said what stage I would be on this year and what topic I would be talking last year, October-ish, I would have said you were crazy that I'd be standing on this particular carpet at HEFF, never been to HEFF before, talking about fleet electrification. I'm a landscape architect by trade. What do I know about electric vehicles and charging stations and all that kind of good stuff? So I'm going to give you a perspective from not an electrical engineer. How many electrical engineers do we have in the room? Just a few, so we won't pay attention to the specifics about the electrical and the overload that we're doing on some of our panels, but we'll talk a little bit about that. So anyways, it's an honor to be here. Nicole, Chris, and others from the HEFF team, the folks that helped me get mic'd up and the presentation slides, thank you, such an opportunity. I'm running solo today. Our Vice President, Dan Bowman, was not able to be here, so we'll see how we go along with this presentation. So let's get started. What am I going to talk about? Well, there's a couple things I think all of us need to know what's going on nationally. Within your state, I live in the state of Michigan. It's where we sort of build some cars. So there might be some different programs available for us in the state of Michigan than perhaps in your particular state. And then what strategically is going on at your university? How can you leverage public-private partnerships? I tell you a little bit about what we're doing at Michigan State for that. Building upon Pete's comment this morning, you got to have evidence to make good decisions. We'll share a little bit about some of the evidence that we're working on in this, and then what's FM's role with research as we go along. So then I'm going to give you a little bit of future considerations that might look different for each one of your universities, each one of your campuses. So what's going on nationally? Well, a couple of key three things. The Bipartisan Infrastructure Law, the Inflation Reduction Act, and the CHIPS and Science Act. Those are all three things that you may not have Googled. We would like you to Google them as one of your key takeaways. There's some money that's available there at the federal level that's pushing out to the different states. And then within the states, you can leverage some of those funds to help you subsidize some of the electric vehicle purchases themselves, as well as the charging station and the infrastructure. So I'll talk a little bit about that today in the conversation. Who knew that there was a National Electric Highway Coalition? I didn't. It's a thing. They're looking at trying to locate charging stations across the national highway. So for all of you that have a university within 1 mile from a highway, pay attention to that particular act because you can get some money from that program. And then lastly, within the state of Michigan, we have what's called Charge Up Michigan program offered by the Office of EAGLE. And we're able to leverage some of the grants from that program, an overall partnership to help us navigate through these different strategies. Now, at the university level, we just conducted a new strategic plan and had 6 buckets, and 2 of those buckets were stewardship and sustainability. And back to what Pete talked about earlier with the baseline of your greenhouse gas emissions, we're using 2010, trying to reduce about 300,000 metric tons of CO2. Who knows what a metric ton of CO2 is? I didn't. It's like planting a couple thousand trees. I'm a landscaper, that makes sense to me. I can plant some trees. So ultimately, we're trying to reduce that while we build additional gross square footage. So that was really cool from the gentleman from Rochester, New York, to talk about his baseline and where they're at with growth of the university. So that's kind of that alignment back to your university. Now, public-private partnerships. I had no idea where to start. And thankfully, Consumers Energy, which is our local utility company, so let me talk a little bit about that. Michigan State University has its own power plant that used to burn coal, now it burns natural gas. We also have a power connection tie line to Consumers Energy, which then runs back to the national grid system within the state of Michigan. So we can do some testing on MSU's campus that could be predictive for the national grid, which is sort of a cool, unique situation. Consumers Energy was a fantastic partner. So if you do not have a current relationship with a utility provider, make a phone call when you get back to your campus because most likely they are working with their state to leverage some of the funding that's coming out federally, and hopefully they can help shepherd you through that process within your campus. Now, they had a consultant on staff by a company name of ICF. There's probably many different consultants that you could leverage to do this fleet electrification study. But ultimately, they have a model that looks at the inputs of your existing baseline fleet. How many vehicles do you have? When did you purchase them? What cost did you pay? Looking at the overall total cost of ownership comparison for how much you spent on fuel, how much you spent on maintenance, what the capital cost difference is between an ICE vehicle versus an electric vehicle. what you're going to pay for charging infrastructure costs, all of that good stuff, as well as what potential grants can you leverage to help subsidize some of this installation over time. So that's that big calculation bucket. And then on the output side, you're ultimately going to develop a roadmap for you and your institution that makes good financial sense, as well as sustainable sense for you to execute this transition over the next, let's say, decade. So at Michigan State, our fleet electrification strategy, this is one of the outputs of it. We have about 1,100 total vehicles, from a Zamboni to a semi-truck and everything in between. Of those 1,100 vehicles, 369 made sense financially for us to convert to EV. Your data is going to look different depending on how many miles you drive, what your overall utilization is of those vehicles. We only average 12 miles a day with our vehicles, 12 miles. So now as I look at an electric vehicle, hey, 100-mile range is pretty sweet because I could run 8 days before I need to plug it in. It'll look different for you depending on how many heavy-duty vehicles you have versus light sedans. Just want you to take all of that in consideration as you're working through it. Now, consultants have models. Models are good. We needed to calibrate the model based upon actual data that we had at Michigan State. So looking at utilization, just talked about mileage, as well as what we paid for those vehicles, what we would pay for electric vehicles, along with what was our actual budget that we have today to spend on new vehicle acquisitions, which is around $2 million. So their original plan that was developed was to have us flip 500 vehicles in year one. Fantastic. If I had $100 to $200 million, I would be happy to flip 500 vehicles in year one and have such a much better outcome of sustainability. But the reality is, for us, we're not going to get $200 million to buy new vehicles. Some of the data that will be produced and outputs are things like this. So total cost of ownership of converting ICE to electric. This is, again, based on that 369 vehicle subset of data. So about $5 million or so total cost of savings per year. Well, I should hopefully still be at the university another 29 years. So I can't wait to kind of run actuals versus what we predicted way back in 2022 and see what happens from there. Fuel cost savings, sure, you're going to save money on fuel. For us, our utility cost is about 9 cents per kilowatt hour, regardless of time of day, because we have our own power plant. So we've been able to negotiate that rate with our local utility company. And so what you don't see represented here is, hey, what are we going to pay in electrical cost? So that's kind of a gap that we're missing in this particular analysis. Maintenance costs. Right now, research says that electric vehicles are around 70% cheaper to maintain than ICE vehicles. Well, no, because all of those vehicles are in our work order management system, tracking actual costs. We can compare against whether or not we actually hit 3.3 million. Back to that, about 300,000 metric tons of CO2. If we convert 369 vehicles, we're looking at around 19,000 metric tons of CO2. So there's a lot of things to consider at a university to move towards your greenhouse gas goals, reduction goals. Fleet is just one of those categories. So I think the previous group talked about that big idea. What's the next big thing you worked on? And I think for most of us in the last decade, we've accomplished a lot of those big things. And now this is sort of like those fine-tuning things. I think your university fleet will want to be one of those fine-tuning things that you can continue to work towards your sustainability goals. Okay, that's kind of big picture, how you can start to align your strategies, work with consultants that do this for a living, and sort of come up with the data and build yourself a model that you can then calibrate and work towards over the next decade or so. Cool? So now let's talk a little bit about what your non-public facing EV strategy is, and then a little later on I'll talk about what our public facing E-strategy is. So we did this pilot. We felt that around 40 vehicles was a good number for us to dip our toes in the water to purchase electric vehicles. These are the different makes and models that we purchased. We bought these vehicles September 30th of 2021, before we knew how we were going to charge them, before we worked with Consumers Energy on the consulting piece, because ultimately our fleet manager, Brian Watts, called me and said, hey, Adam, if we don't hit go today, you're not going to get those vehicles in 2022. Of these 40, we have received all of them except for one Ford Lightning pickup truck. And I'll talk a little bit about what we paid for these, what we would pay today if we buy these same 40 vehicles, and a little bit of everything in between. So for the CFOs in the room, hopefully this will be worth your time. Okay, what was our goal? What's our pilot? What are we trying to achieve? Well, we want to analyze a little bit of everything. The vehicles, the battery performance. We're going to leverage a charge management, electrical load software. What's that? I'll talk a little bit about that. the overall vehicle performance, battery life. What can I sell these electric vehicles? What will consumers pay for a used electric vehicle that has, let's say, 80% remaining battery life? What will somebody pay, right? I know what they'll pay for ICE vehicles because we've been buying and selling ICE vehicles for the last 30 years, but we haven't been doing that with EVs. So how does that fit into your overall total cost of ownership? I'll talk a little bit about that. So now let's hop into the numbers. I don't know if this is too small for you or not, but ultimately, what I'm trying to compare for all of us, we've got a bucket on capital purchase. That's the cost difference between ICE and EVs. And there's a premium for EVs, shocker, if you've tried to buy an EV yourself. About $453,000 premium for the exact same make and model of an ICE vehicle compared to the EV that we went with. So think of that, keep that in the top of your mind. So then I looked at fuel and maintenance costs for the vehicles that we have. And thankfully, we have all the data. So we know exactly the particular categories of vehicles that we're replacing, what we spent on fuel, what we spent on the maintenance of those vehicles, and what that difference is, which is about $421,000 total dollars. So then bottom line, you take, this is just looking at vehicles, by the way. The charging calculations is something different in infrastructure, but just the vehicle acquisition. Bottom line, you got a premium of $453,000 for the capital costs for EVs. We're going to back out some fuel costs of about $183,000, back out some maintenance. So again, I talked about 70% cheaper to own an EV for maintenance percent compared to an ICE. So we back out a little bit of that. I don't know what's going to cost electricity. I have no idea how many kilowatt hours 40 vehicles are going to run up over the next decade. So I've got that as a placeholder. But right now, just looking at the vehicle, it's about $140,000, $150,000 premium. If I did the same calculation today, what we paid for these vehicles, it would be somewhere around $250,000 to $270,000 premium. So for those of you who haven't purchased an electric vehicle yet, you may want to hang on for a little bit because the price is really, really expensive. I've heard of different universities' orders being canceled, their fleet orders, because the manufacturers are able to resell those same vehicles for retail. So there's a lot of things going on in this industry right now that you just need to take an evidence-based approach so that you can factor all of these things within one side of the house that's saying, hey, we've got to do this to be green. The other side, CFO side of the house saying, wait a minute, how am I going to afford this? Does this really make sense? What's the return on investment? Okay? All right, charging strategy. So if I was going to blow up a building on campus by overloading electrical circuits, I would probably rather do it to the facility folks than I would like College of Engineering, for example. So we're picking the IPF building. We strategically located charging stations close to the building to save on electrical wiring and all that kind of good stuff. Within our building, for the electrical engineers, we had a 1200 amp panel that just happened to have 3 vacant breakers. And so we bought 3 400 amp breakers that still aren't here yet, that are coming eventually. So we bagged and borrowed from different panels that we had that weren't utilized, and we plugged them in. We are lighting up 80 amp Ford Pro charging stations, which if you start to look at the quantities of vehicles in each one of these locations, you would quickly identify, wow, you're not an electrical engineer, and who put you in charge of this project? That's where the load management software comes in that allows you to basically not blow up your panel, not break breakers, and allows you to basically overload your design of your charging station, your system, by having a software that manages the building available electrical capacity from the demand of having so many vehicles plugged into it. Okay, so that was a thing. I didn't know that. Hopefully, if you didn't know that, you learned something new today. Installation, pretty straightforward, right? You dig a trench, throw some conduits in. The one key thing I think to note on this is we're using 80 amp Ford Pro charging stations that allow you to dial it all the way back to 10 amps or so. So actually, because of our capacity on the panel of 400 amps, we actually had to dial back most of these charging stations to 48 amps. Eventually, I'll switch to a different strategy of using our medium volt duct bank that I'll talk about a little bit later. And we can start to turn up the energy here on these 80 amp. All it truly means is you can charge your vehicles quicker without screwing things up. So that might be more important for a fleet that delivers things on a day-to-day basis than it would necessarily for our particular fleet that only drives 12 miles a day. So these are all things you need to evaluate of how fast you need to charge, right? That whole range anxiety piece. Really know your numbers on what your current utilization is, and then make good, smart financial decisions on what charging stations you go with. Collaborative research. So we looked at the College of Engineering It's a couple of brilliant faculty like all of your colleges do. And we pulled them into this project to do some research for us. So they're gonna help me analyze and the team analyze the vehicle life cycle cost, again, from what we paid for it versus what we're gonna sell it for at the end. Look at that load management performance. How many times do we blow up things or don't we? And then lastly, the electrical battery performance. And it's not only the battery performance based on your utilization, but also there's some research right now that says if you charge your vehicle to 80% total power, that you can prolong the life of the battery. We're going to assess that. We could get away with that with only driving 12 miles a day to only have 80% charging, on a full battery. So maybe a battery is warranted today with Ford vehicles for 8 years. So maybe I can actually get 12 years. 13 years based upon some smart charging strategy. But also, I'm gonna talk a little bit later on in the research piece is, what are we gonna do with those vehicle batteries at the end? What's our responsibility as an entity to buy an asset and truly understand its total life cycle costs and what we're gonna do with those raw materials? So we're actually researching right now with a couple grants, looking at pulling out the vehicle battery at about 80% remaining life and dropping it into a battery storage solution tied into our solar energy to try to smooth out those peaks when clouds go over campus. So I'll talk a little bit about that as we go along. So don't just do this to do it. Pull your faculty members in, pull your students in, do some research as you go through this journey. All right, so let's talk a little bit about public-facing EV strategy. On campus today, we have about 14, that's it, 14 level 2 chargers. They're all on the ChargePoint platform. There's other very similar platforms, and I'm not giving a plug to them or anything like that. We are also leveraging the installation of 2 DC fast charging stations. And the difference between a level 2 and a DC fast is a level 2 is something you would have at your house. You plug it in when you get home from your day. It'll charge over an 8 to 10 hour period, and you're ready to go full battery at the next day. So longer charging time, lower amperage. These 2 DC fast charging stations are only a 62.5 kilowatt hour unit for the electrical engineers in the room. I don't know what that means, but it means that I can charge a vehicle in about 20 minutes, okay, compared to 8 hours. So the problem with DC fast right now is the current battery technology with lithium ion gets damaged from repetitive charging of DC fasts. So I was thinking initially, why don't I just install a fuel pump, if you will, of DC fast charging stations on campus and reduce the total number of infrastructure items I have to have on here that will have a life cycle of like 8 years, let's say, for a level 2 charger that I have to replace over the life of it, and just do a couple DC fast to serve both the public and the university fleet. Issue is the current battery technology gets damaged from doing that. So I don't really want to do that with the university fleet, nor do I really want to do that to the public. So we're looking at all of these things, but I think this key question is for all of us in the room, and I don't have enough time to field the questions, so we can talk afterwards, but how many should we install? What's the responsibility of a university for installing public-facing charging stations? What is that? Has anyone had an opportunity to navigate that question with your president? I think that's something you definitely need to talk about over the next couple of years. Okay. So I talked a little earlier about that National Highway Coalition of charging stations. And what they're looking at is that national highway network across the nation to identify where to select and locate charging stations. And one of our faculty members in the College of Engineering worked with the state of Michigan Eagle to look at our highway network in the state of Michigan to identify charging station locations. These are DC fast charging stations. And lo and behold, in the Lansing area, there are predicted to have 10. So we applied for 2 of those, and we were selected. At the university, we looked at a couple different things of where to site these locations. So if you think about people that are traveling, most often on a vacation, would probably stop and use a DC fast charging station because they want to get to their final destination. They don't want to spend 8 to 10 hours on the level 2, and they want to keep going on their trip. So that's part of the reason why they would use a DC fast charging station. So when you stop, you probably need to go to the restroom, you probably need to grab some food. So these are all kind of considerations of what parking lot you place these particular units at. And so all of those things sort of arrived for this particular site, which is kind of located in the south bottom right corner of the drawing. It's a site that's called the CATA Multimodal Station. It has an Amtrak station, so for those that want to jump on a train, go to Chicago, for the weekend, they can park their vehicle here. They can take a local area transit bus to get here, get off, jump on a train, get out of here. Or they can take what's called the Michigan Flyer, a Greyhound bus that would take them to Chicago or to Detroit, to Grand Rapids, that regional transit on a bus. So this site made really good sense holistically to select for this particular location. Now the funding piece. So we are projecting, we're right in the middle of installation on this, and our electrical panel just got delayed again. It was supposed to be delivered in July, now it's March of 23. Which is really quite unfortunate. So just as long as you place a vehicle order here next month, let's say, you probably won't get delivery until 2024. Probably same thing goes for your transformers and your electrical sub-panels on some of these particular projects. So I just wanted to kind of set expectations for you. Those that have really good relationships with Square D and Siemens, like any campus would, or pick your vendor of electrical equipment, the supply chain is just tough right now. So for this particular project, rough budget, $228,000. We were able to leverage $70K from Eagle for their Charge Up Michigan grant. That was the alignment with the highway network. And then another $70K from Consumers Energy. Our local utility also installed the transformer for free for us and set us up, and then we had to go from sub-panel to these 2 charging stations and burden that cost, which is around $88,000. We then split it as a partnership between the Capital Area Transit Authority and Michigan State. The pro forma spreadsheet's probably way too small for you to see. You will have access to these slides at the end, so don't worry about taking a bunch of notes. You can have it, you can give me a call afterwards. But ultimately, I'm looking at about a 5-year break-even point with a few assumptions. How many people are gonna buy an electric vehicle in the next 5 years? How many are gonna choose these 2 charging stations to select on their journey versus the other 2 that are 10 miles north of me? And how much time are they going to spend, how much energy are they going to use? All of those factors are in the spreadsheet. You will have access to all those assumptions. I worked with Consumers Energy, and they actually had data from all of the DC fast charging stations that have been installed across the entire state of Michigan. They have a utilization rate of only 1.2 charge sessions per day, and only about 25 kilowatt hours per charging session. So if you're trying to make 50 cents a kilowatt hour on only that amount of utilization, that return on investment is going to be more like 50 years, okay? So there's a couple assumptions that are built in this spreadsheet. I'd be happy to walk it through with your folks when you get back to campus. Just things you want to put in mind or put in consideration. All right, hey, we're doing pretty good on time. Future considerations. So I talked a little earlier about overloading our building electrical equipment. And what you'll probably learn, unless you had really great budgets back when you built your buildings and were able to design your electrical equipment, which we didn't, you will learn very quickly that to install electric vehicle charging stations of any volume, let's say 25 charging stations at a building, and try to plug that into your building, you're going to hit an electrical demand almost equivalent to what the building is today. And so to upgrade all of that equipment within that electrical mechanical room is really not feasible with the walls that are all concrete and the size of the equipment and the offset that you need. So our new strategy 2 weeks ago was, hey, we have our own power plant. We have duct banks that all this medium voltage with different circuits run from the plant to light up, let's say, 10 buildings on campus. Why don't we tap into those and set up a transformer, and then set up sub-panels from the transformer and light up our charging station installations that way and completely avoid our buildings. What does that do? Create some pretty resilient systems. So now we don't have to worry about going back in and, for example, our public safety building on campus would cost around $850,000 to retrofit the existing electrical equipment in the electrical substation, versus a medium volt solution of around $480,000. So we're going medium volt on that particular installation. So I just wanted to kind of point that out to you because what that'll end up allowing you to do, if you have your own power plant or your local utility, same thing, is leverage some of their load management electrical software that they already have at the plant level and use that from a circuit perspective. Now I'm really stepping out of my league from an electrical engineering standpoint, and dial that back depending on what makes sense, depending on how many vehicles you're able to acquire and how many charging stations you install. Does that make sense? Okay, cool. So that's one thing you need to consider in the future. Michigan State is a land-grant institution, pretty cool. We have about 26,000 acres across the state of Michigan. And we're doing a study right now to identify areas of the state that do not have charging stations currently installed. There's a lot. But where are these locations that are, let's say, 150 to 200 miles from the nearest charging station? And does MSU own land within that little pocket of the state? If we do, we're going to run the math to see if we can actually install level 2 charging stations or DC fast charging stations at some of these locations. And again, I'm going to leverage the highway network to try to pull in more grant funding, and then that would be a DC fast. to ultimately install some charging stations across the state of Michigan, not only for the university business travel that happens across the state, but also make them publicly accessible in these rural areas that will ultimately help this overall, I guess, shift from ICE vehicles to electric vehicles. So that's a little area that I'm looking at. We're going to try to develop a cost model that makes sense so that we can ultimately repay back that initial investment on these, and then put some money aside for the replacement of these devices long term. So if you have a situation like this, or you could be a part of a coalition within your state to leverage some of these opportunities, take a look at your land from a real estate perspective and how you might be able to tap into that market. And then I talked a little bit about this, so we just applied for a DOE energy grant that we should hear about any day. And the whole innovation on this is a faculty member that has developed a topology that allows you to, wow, now I'm really getting out of my element here, plug in multiple different vehicle battery makes and manufacturers that are at different charging states, so that you can ultimately pull those in through an inverter, and then when the cloud comes over the campus and our solar energy goes from 10 megawatts per hour to 2 megawatts per hour, it automatically transfers over to a battery storage solution that has vehicle batteries in there. So our proposal was to do 2 megawatts of vehicle batteries for 30 minutes of time, and we will swap in and out these vehicle batteries as their cells begin to die, if you will. So the topology here, the innovation, is that it's able to determine which cells are active and which aren't. And typically right now the technology is if one cell is bad, the whole battery is dead. But this one is able to, we'll see if we can actually build it, able to identify and work through that. So I think that'll serve as sort of maybe our responsibility as buying these assets, and overall what's the long-term use of those. So the idea would be we pull a vehicle battery out at 80%, plug it into this, we run that battery down to about 40% or so is what the industry says, that's pretty much end of useful life. And then from there we move it on to a battery recycler that we have in the state of Michigan, who would take that down to the raw materials, push it back into different industries. So those are some of the things that we're looking at and considering in the future. And I promised you a couple key takeaways. Partnerships are critical, like all things in life. And I think especially post-COVID, when we have the opportunity, I love that conversation this morning about what does culture look like? How do you onboard employees in a remote environment? And how do you embed them into your culture? What is your culture now today? I think this is a great opportunity for any topic that we're getting into to look at partnerships and what you can do from there. Develop a roadmap, adjust your roadmap. I talked earlier about the vehicle price change and the cost. We are re-engaging ICF to rerun the model for us here in December. We've bought some vehicles, we've sold some vehicles, so all of that data very easily we can plug back into the model and readjust. Maybe we can do 390 vehicles in the next decade, or maybe because they cost so much, maybe it's only 300 vehicles. We're going to continue to calibrate that year after year so we can make good financial decisions. My suggestion would be to slow play the installation of your level 2 chargers on campus. Let's wait for brilliant people to design a new battery that doesn't get negatively impacted from DC charging, and then only install a couple DC fast charging stations on your campus as a smaller footprint of infrastructure installed for both your public-facing strategy and your non-public facing fleet strategy. Okay? And then lastly, research. I think it's really important for all of us to take an evidence-based approach with what we're doing here today. Be flexible. This industry is literally changing all the time and transforming all the time. The state of Michigan, which is where a lot of the auto industry is, obviously, is installing a lot of battery plants. We're installing a lot of chip manufacturing plants. There's a lot of things going on in the state of Michigan that a university is primed to be a good partner with. So I think leverage what you're good at in your respective institutions, build relationships, and hang on, because it's going to be a really exciting ride. So with that, I've got a minute left. Sweet. I guess I can field a question, if you're okay with that, Nicole. 1 or 2 questions? Put me on the spot. Yes, sir.
You have buses in your formula?
Yeah, Michigan State, I don't know, 15 years ago or so, used to provide all the on-campus busing. We sold that system to the local area regional system. We now have about 5 buses that are over-the-road motor coaches, take people to the airport, buses, et cetera. But we are researching right now a company, a bus that was manufactured in Turkey by a manufacturer called Carson, and an autonomous company called Adastic. And we are just launched this year in May, the first in the nation fully sized bus, 22 passenger, fully electric, fully autonomous, level 4 that I wish I would have put in the presentation because I showed that video, but good question. So yeah, buses are an aspect of this overall decision. 20 seconds, one more question. Yes, sir.
Adam, many of us obviously have parking spots, we charge for them, we make money on them, so the shift of a parking spot that students pay for, faculty pay for, now it's transitioning, not a lot, but some of them towards a public parking spot. So you get this dynamic of obviously getting in conflict with your parking system that loses income for the sake of having these charging stations. So what are your thoughts on that dynamic?
Analyze the cost centers at your institution, pull people together, build partnerships, and reassess that, reevaluate that on an annual basis. Great comment. I'll be around for the rest of the conference. Happy to talk to you more in detail. Thank you so much for the opportunity, Nicole.